Hello, grade 11s. We are now going on to nominal and effective rates. What I've done here is I've just printed 2 slides per paper. Okay, so you can copy all of this down into your books. Let's just read through it. It says here, interest rates are usually quoted as percentages per annum. In other words, per year. Interest can, however, be compounded or added at regular intervals, any regular interval during the year. The most common compounding periods are daily, monthly, quarterly, and semi-annually. So what does this mean to us? Well, consider the growth of an investment of 100 Rand over 1 year, where interest is compounded quarterly as opposed to annually. First, calculate the value of the investment at the end of 1 year if the interest rate is 8% per annum compounded annually. So what we've got here is just a normal compound interest problem, okay? And so we've got A is equal to, P is equal to, I is equal to, N is equal to. So the accumulated amount, we don't know. The principal amount was 100 Rand. The interest rate is 8%. And the time period for this is 1 for 1 year. So A is equal to P, 1 plus I to the power of N. And we get 100 plus 8 over 100 to the power of 1. So A is equal to the power of 1. So normally we would get 108 Rand after the first year. Now, what I want you to notice here is that it's just compounded annually. Okay, so now what we're going to do is we're going to change things around. So now, suppose that interest is added at the end of every quarter instead of at the end of every year. So now what we're doing is we're compounding it quarterly. Okay. The interest rate is now 8% per annum compounded quarterly. The rate of 8% is now evenly divided between the 4 quarters of the year instead of only paying 8% at the end of the year. How much interest is added every quarter? In other words, what is the quarterly interest rate? Well, what we have to do is we have to take our 8%. Okay, so that's our normal 8%. And what we need to do now is we need to divide that by 4. We need to break it down into the compound period, which they told us was quarterly. Okay, just do this on the calculator. And you've got 8 over 100 and divided by 4. And now we're getting an interest rate of 0.2. To put that back into percent, what we do is we just multiply that by 100. So if I do it over here, 0.02, to put it back into percent, multiply it by 100. And what we're getting now is we're getting 2%. And what this is, it's per compounded quarterly. So I'm just going to say CQ, compounded quarterly. Okay. Right, so let's have a look at the next one. So record the value of this investment at the end of every quarter. Now be very careful there, grade 11s. We are now compounding it every quarter, not every year or per annum. Okay. Using the table below. Express the values rounded off to the nearest cent, but do not round the answers during the calculation. In other words, on your calculator. So at the end of the first year, what we're going to do is now we're going to compound it quarterly. So I'm still going to be using the compound interest formula. A is equal to P, 1 plus I to the power of N. Okay. Now what we initially invested was the 100 Rand. So here we've got 100, 1 plus. Now my interest rate is this 0.02, which is 2%. So what we can say here is 2 over 100. And that was compounded for 1 quarter. So that's to the power of 1. and we get 102 Rand for the first quarter. Okay, now what I'm going to do is I'm going to take that 102 Rand and add interest to that. So I'll just change that to 102. Same thing, interest is still 2% per quarter, compounded quarterly. And what we get now is we get 104 Rand and 4 cents. Okay, so for the third quarter, I've changed this now to 104 Rand and 4 cents, still 2%, and we get 106 and 12 cents. Then for that last quarter, we're now going to add interest onto this amount. So that's 106 and 12 cents. Still the same interest and still 1 quarter. And we get 108 Rand and 24 cents. Okay. So notice that the accumulated amount of the investment after 1 year, because there's 4 quarters in a year, is now greater than the amount in our original calculation. So remember with the original one, if we just had the normal compound interest, we got 108 Rand. But now if we compound it quarterly instead of annually, we're now getting 108 Rand and 24 cents. Now, which is greater than the original calculation. Okay, the reason for this is that interest has been added or compounded more frequently during the year. Now, I know you're probably thinking that 24 cents isn't a lot, but guys, if you're investing huge amounts of money, this will grow very quickly, okay, compared to the original one. All right. So, nominal and effective rates. Now, use the compound interest formula to determine the rate of interest per annum to 2 decimal places, compounded annually at the end of every year, that would yield the same accumulated amount as in the table. So what they want now is they're asking, okay, if we had to compound this thing annually, what would our interest rate be? So over here, if we compounded it annually at 8%, we get 108 Rand. But for this one over here, what would be the equivalent compound interest per annum that will give us the same amount? Okay, and that's what they're asking here. So we've got A is equal to, so our accumulated amount here would be the 108 Rand and 24 cents. The principal amount is 100 Rand. The interest rate, we don't know. That's what they're asking. And our time period is 1. So A is equal to P, 1 plus I to the power of N. 10824 equals 100. 1 plus I to the power of 1. Okay. So I'm going to divide by 100. So it's 108.24 divided by 100. And we get 1,0824 equals 1 plus I. So I subtract 1 from that, and I get I is equal to 0,0824. Now remember, to put that back into percent, I multiply by 100, and we get an interest rate of 8.24% per annum. Okay, so from the original one, it was 8%. For an annual interest rate for this one, not compounded quarterly but per annum, per year, would give an equivalent of 8.24%. Okay, and you can see that this interest rate is bigger than this interest rate that we initially had. Okay, this is called the effective interest rate because it is the actual rate of interest earned per annum. The effective interest rate is denoted by I. Okay, so if they say that you've got a per annum rate compounded quarterly, that is not the interest rate that's doing the work on your money. It's this effective rate that's doing the work. Okay, so let's have a look. See here, the quoted rate of interest is called the nominal interest rate, because it is the interest rate in name only and is not the rate which is actually earned. The nominal interest rate compounded m times per annum is denoted by Im. Okay, now this is not a power, guys. This is not an exponent. Note that the index m is not an exponent. It is part of the interest rate symbol and it indicates the number of compoundings per annum. Okay, so for example, in our example, we had 8% per annum compounded quarterly. This can be written as I4 because there's 4 quarters in the year and it's equal to 0.08. Remember, you just take the 8% over 100. Okay, now try these. 9.1% per annum compounded monthly can be written as, now, how many months are in a year? We always look at a year in a year, guys. So there are 12 months, so it's I12 equals 0.091. How did we get that 0.091? Well, we just took the 9.1 over 100. And you get that. Okay, so for the next one, they're asking 3.7% per annum compounded semi-annually can be written as. Now, how many semi-annuallys are there? So in other words, if you break a year down into semis, it's 2. So this would be I2 equals. Convert this into a decimal and you get 3.7 over 100. And you get 0.037. Okay. 14.5% per annum compounded daily. Now, how many days are in a year? There's 365. Now, guys, don't worry about a leap year and all of that. Just take it as 365. Okay. So we take 14.5 over 100. And we get 0.145. Okay, 21.9% per annum compounded biannually, which is once every 2 years, can be written as. So if we're doing it biannually or every 2 years, that means that we are doing it every, it's going to be I to the half. Biannually, every second year. Okay, so equals. You take that, 21.9, and you divide that by 100. And we get 0.219. Okay, guys, so it's just as easy as that. Right, going on to the next slide. Now, guys, there's a whole lot of stuff that's going to be going on here that you're going to find a little bit confusing. Don't worry about it. When I get to the examples, I will show you a nice, easy way of doing all of this. Okay, so just listen up for now. Once I get to the examples, you'll see how much easier it is. Okay, so for nominal interest rates, the quoted interest rate period and the compounding period are different. For example, 8% per annum compounded quarterly is quoted per year, that per annum part, but interest is compounded on a quarterly basis. So they said here 8% per annum, or in other words, 8% per year, compounded quarterly. You have 2 different time periods there. Okay. For effective interest rates, the quoted interest rate period and the compounding period must be the same. For example, our effective rate, 8.24% per annum, compounded annually. So the rate is quoted and compounded per year. All right. The quarterly effective rate we calculated above is 2% per quarter, compounded quarterly, since I4 over 4 is your 8% divided by the quarter, which gives us the 0.02. Since this is an effective rate, the interest rate period and the compounding period once again match. Okay, in general, the effective rate of any period M is then I to the M over M. Blah, 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 guys. Don't worry. Okay, I'm going to show you now in an example how we do this. Okay, so we have now in the past, we have used the compound interest formula A is equal to P, 1 plus I to the power of N, with an annual effective interest rate and a time period of years. Okay, that's important. So your interest rate was per annum, and it was asking in a period of years. How many years? 2, 3 years, and so on. Okay. We can now adapt this formula to use an effective rate per period and the corresponding total number of periods MN. Again, guys, blah, 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 blah. Okay, I am going to show you now with this example over here. So they told us here that 10,000 Rand is placed in a fixed deposit for 5 years. Determine the maturity value of the deposit if it earns 10.1% per annum compounded monthly. Right, so example 1. So we have A equals, P equals, I equals, N equals. So what they want to know with this question is what's the value of this thing at maturity. So the accumulated amount, we don't know. Now, the principal amount will be 10,000. Our interest rate is 10.1%, so that's 10.1 over 100. And I just want to make a note here, guys. They said it's 10.1% per annum compounded monthly. So I'm just going to say here CM, compounded monthly. And how many years? 5 years. Okay, and now this is in years. So what this part over here was talking about, all of this, with them not being in the same units and things like that. If we have a look here, this one is compounded monthly, so it's a monthly time period, and this is in years. These are two different units of time. We cannot compare these two. So in order to get this right, what I need to do is I need to divide the interest rate by 12. Now, where am I getting the 12 from? Well, how many months are in a year? There's 12. I divide this one by 12 and I multiply this one by 12. Okay, so we've got this 10.1 over 100 divide by 12. And our interest rate now is this 101 over 12,000. Okay, over here, 5 times 12 is 60. What I've done now is I've converted it that they're in the same units of time. Okay, they're both quarterlies now. Okay, and those are the ones I'm going to use in the formula now. So we've got here A is equal to P, 1 plus I to the power of N. Okay, just substitute in. So we've got 10,000, 1 plus 101 over 12,000 to the power of 60. You can just plug this on the calculator, guys. And we get a final value of 16,534 Rand and 87 cents. Okay, so as easy as that, guys. Always divide your interest by the compound period times the N by the compound period. Okay, so let's have a look at example 2. The value of a unit trust account is currently 237,892 Rand and 31 cents. What was the value of the account 3 years ago if the unit earned on an average interest rate of 17.6% per annum compounded daily? Okay, so this one we have to work backwards. We've got the final amount, we just need to work out the principal amount. Okay, so example 2. We've got A equals P, A is equal to, P is equal to, I is equal to, N is equal to. So our accumulated amount, they told us, was this 237,000 892 Rand and 31 cents. We want to work out what the principal amount was. Now, coming back to the question, they told us it was 17.6%. So 17.6 over 100. And it was compounded daily. So I just want to make a note here, compounded daily. And it was 3 years ago. So this is 3. And this is in years. So before I continue with this question, guys, you can see that our time periods are different. Here we've got days, here we've got years. So I ask myself, how many days are in a year? So it's 365. So I divide this by 365 and I times this one by 365. Okay. If you put this on the calculator, you just do it like this. 17.6 over 100. Divide that by 365 and you get this fraction here. 22 over 45,625. Here I've got to take 3 times 365 and we get 1,095. Now those are the values I'm going to be using in our formula. Okay, so A is equal to P 1 plus I to the power of n. Our accumulated amount is this. Equals P 1 plus our interest is now this value over here, 22 over 45,625 to the power of this value over here. Okay, and we want to get the P on its own, guys. So what I do is I work out what this is over here. 1 plus 22 over 45,625 to the power of 1095. Okay, and I get an answer. Now that's what that's giving me. So I need to divide by this to get the P on its own. So I need to divide that number by whatever this answer was. So we're going to take 237,892,31 divided by that answer that we got. And we get a final amount of 140,322 Rand and 78 cents. Okay. Going on to the last example here, guys. Okay. So the last example here is saying a loan of 25,000 is created. How much must be repaid after 4 years if the lender charges 10% per annum compounded semi-annually for the first 2 years and 10% per annum compounded annually thereafter? Okay, so what's happening here is we've got a change in interest rate. So I'm going to look at 2 scenarios for this. So the first thing is, so this is example 3. The accumulated amount we don't know. Okay, the principal amount was 25,000. Now here comes where we're going to change things a little bit. So I've got the scenario 1, okay, where they told us that the interest rate is 10% per annum compounded semi-annually. So our interest rate here is 10% over 100. And our n is equal to, and they say here for the first 2 years. So this is 2. Now, this interest rate is compounded semi-annually. So semi-annually, and this is in years. These are in 2 different units, semi-annually and years. So I need to divide this by 2, and I need to times that by 2. So 10 over 100, divide that by 2, and we get 1 over 20. Over here we will get 4. Okay, now there's a change in our interest. So scenario 2, where they told us now that it's 10% per annum compounded annually. Okay, so this is 10%. And this is compounded annually. And our n is equal to, it has to be for another 2 years because it's a total of 4 years. And this is in years. Okay, so here we have annually and here we have years. These are in the same unit, so I don't have to do anything. I don't have to change these because they're not in different units. Compounded annually is the same as saying compounded yearly, and this is in years. Okay, so we can leave those just as they are. Now here comes the trick, guys. We know that we have to use this formula. A is equal to P 1 plus I to the power of n. And what we have to do is we have to incorporate both of these interests in it. So what I do is I say the accumulated amount will be equal to 25,000. Now what I'm going to do is I'm going to do it for the scenario 1 here. So we get 1 plus our interest rate is 1 over 20 and our n is 4. Now we're going to scenario 2. So I need to add that interest on. So it's just this bit here that I'm looking at. Okay, so I've added it for scenario 1. Now I'm going to do it for scenario 2. So 1 plus, what is our interest? 10 over 100. And it's to the power of 2. All right. We can just plug that on the calculator. So we get 25,000. 1 plus 1 over 20 to the power of 4. Then our next interest, 1 plus 10 over 100 to the power of 2. And we get a final amount of 36,769 Rand and 6 cents. Okay. And that is it. That's how we tackle a question like that, guys. Right, so for homework, what you can do for me is you can do exercise 12.2, number 2, 5, 8, 9, 10, 11, and 15. Thanks, guys.